let's talk about the alphabet. The alphabet? Why are we talking about the alphabet? I want to introduce you to the Greek alphabet. I'm just going to show you a few letters. Greek letters are often used to represent angles. So when we're dealing with the measure of an angle, often they'll use a Greek letter like alpha or beta or theta. Alpha and beta. Let me show you something cool before we get started. The first two letters of the Greek alphabet are alpha and beta. That's a terrible beta. Let me fix it a little bit. I've made it worse. Here we go. It's like a B, only the top part is smaller than we're used to seeing. It's kind of like that. And this is where we get the letter A and the letter B from. So this is alpha, and this is beta. See it? You see where I'm going with this? That's where we get the word alphabet from. So alphabet. The one we're going to use the most, though, the Greek letter that we're going to use the most when we're talking about the measure of an angle is the letter theta. It's basically like a zero with a kind of a slash through it in a way. This is called theta. And almost any Greek letter is conventionally used in a way that would measure that would show the measure of an angle. This one most of the time, though. Okay, so we're going to be talking about right triangles, and in talking about right triangles, we're going to be finding the measure of missing sides. So let me say something really quickly. When we have a right triangle, our first thought often is to do something with the Pythagorean theorem, and that's fantastic, but here's where it changes. We're not going to always use the Pythagorean theorem because we won't have enough information. Let's suppose that we know the measure of this side and the measure of this side, but we don't know this one, we'll call it C. We can use the Pythagorean theorem. That's fine. However, what if we know two sides? What if we know one side, I'm going to get a mess here, and we know the measure of an angle, 23 degrees. Then what? We're going to have to use this thing called trigonometry. And in order to use trigonometry, we're going to have to know how to identify the different parts of a triangle. So, in a right triangle, there are three sides. Obviously, in any triangle, there are three sides. But the three sides have special names. The two sides that meet to make the right angle are called legs. I'm going to erase this 23-degree angle. These two are called legs. This is a leg, and this is a leg. And always the longest side, which is the one across from the right angle, that one's called the hypotenuse. Hypotenuse, hypotenuse. And we're going to get a little more specific with this. So if I am standing beside someone, then I could say I'm adjacent to them. So what I'm going to do is introduce you to three words. You just met one of them, the hypotenuse. But I'm going to introduce you to three words within the context of a triangle. Let's draw a triangle. I'm going to erase theta here. And let's just random triangle, random right triangle, there we go. And we'll call that theta, and I'm just going to make up some stuff. Let's suppose that this side is 7, this side is 24, not drawn to scale, obviously, and this is 25 units long. Okay. Let's start with the word that I just showed you, and that's adjacent. I'm going to find the leg that is adjacent to the angle that I'm dealing with. The angle I'm dealing with is angle theta. This little corner right here, I don't know how much it is, 17 degrees, 75 degrees, who knows? We don't know what it is. There is a way to find it, we'll deal with that later. But in relation to this angle, I am looking for what I call the adjacent leg. Okay, in order to find the adjacent leg, then we're going to have to start by saying, you know what, I know what this is. This is the hypotenuse. There we go. There's the hypotenuse. The 25 is the hypotenuse. Well, what's adjacent to the theta? Well, we could say that this is adjacent to it, but it's not the adjacent leg. I'm going to call this side, this leg right here, the adjacent leg. Well, if this one is adjacent, what does that make that one? Well, you're standing in one corner of the room and someone else is way on the other side of the room. You would say that you are opposite the room from them. So this side is opposite from our angle theta. So that is opposite. So here are the three words we're going to use a lot in trigonometry. We're going to use opposite, adjacent, and hypotenuse. We're also going to use three other words that you'll see on your paper. It's sine, cosine, and tangent. But we have to understand opposite, adjacent, and hypotenuse first. So I'm going to draw one more just so we can kind of see where this whole thing is going. Let me find a good marker. There it is. Just drawing a random right triangle. And let's let this side be, trying to think of a good one. Can't just make up stuff, it has to work. Let's just do 3, 4, 5. 3, 4, 5 is a very common right triangle. And I'm going to use the angle alpha. Let's use alpha, okay? And I'm going to let alpha be up here. Let's say that this angle up here is alpha. Well, what's this one? Well, I don't know. Call it beta, call it theta, call it whatever. But I'm dealing with this one. So in pretty much any right triangle situation that involves trigonometry, we are going to be dealing with an angle that it either gives you or it's labeled or that you are dealing with that you know somehow. And we need to figure out how to label every side. Let's start with the obvious. I like to go for the hypotenuse first. What is the longest side in this triangle? It's the 5. This is the hypotenuse. Okay, well that's great. What does that mean for the other ones? Okay, I have two other options. I have opposite and I have adjacent. Opposite is across from. If this is my angle, then what is across from my angle? Well, the 4 is beside my angle. The 3 is opposite. It is across from it. This side right here never touches that angle. So I'm going to call this one opposite. Opposite. And I'm going to call this one adjacent. And there we go. We've gotten a little bit of review on opposite, adjacent, and hypotenuse and gained a deeper understanding of triangles. Again, not using the Pythagorean theorem because I'm not finding the measurement of a side while ignoring the angles. Okay? This is going to make a little more sense as we get deeper into it. So the three trigonometric ratios, comes from trigonometry, the three trigonometric ratios that you are going to need the most are these three right here. They're called sine, cosine, and tangent. They are abbreviated with the first three letters, so when you see S-I-N in math, from now on you will call it sine, not sin. C-O-S is cosine, and T-A-N is tangent. So sine is some of the words that we've already discussed. It is the opposite side divided by the hypotenuse. It is a ratio. Hypotenuse. Forgot how to spell it for a second there. It is the opposite divided by the hypotenuse. The cosine is the adjacent divided by the hypotenuse. And tangent is opposite divided by adjacent. Do you have to memorize that? Well, you'll memorize it very, very shortly. Here you go. Let me zoom in a little bit there for you. Okay, so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And the way some people memorize it is this. They'll say S-O-H-C-A-H-T-O-A. Okay? Some people pronounce it SOHCAHTOA. When I was in high school, my teacher said Oscar had a heap of apples, and that's how I memorized it. So there are other ways of memorizing it as well. What we're going to do is write those ratios with this right here. So here goes. We have three angles in this triangle, obviously, because triangle means three, so there are three angles. There is alpha, theta, and then the right angle. And we're not going to deal with the right angle. The right angle just gives us permission to do this and set up right triangle trigonometry. All right, triangle trigonometric ratios. So the sine of alpha. Okay, let's not think too hard. I'm going to switch to pencil for a second. If I can find one in here. I found one, yeah. This is the one I'm thinking of. It doesn't work too well, so this may not end well. I'm going to label these in pencil because I'm going to erase them. But going from alpha, let's label everything. I'm going to label it in pencil, like I said, so I can erase it. The first thing I like to identify in any triangle, doesn't matter what angle I'm dealing with, I know this is the hypotenuse. All right, pencil's working. So far, so good. I had a pencil that looked like this that had a very soft lead and it broke all the time. This doesn't seem to be it. Okay, from alpha, I have two other sides I need to label. I need to label this one and I need to label this one. So I have to think, which one of these two sides touches alpha and which one of them doesn't touch alpha? The one that touches alpha is adjacent. That's this side. So this is adjacent. Adjacent. And then the one that doesn't touch it is opposite. It's away from it. So this one is opposite. Now, when I'm dealing with theta, this will change. But for now, this is the way it is because I'm dealing with alpha. Okay, let's come over here and talk about the sine, the cosine, and the tangent. The sine of alpha. Well, sine is opposite divided by hypotenuse. Opposite is 8, hypotenuse is 17. So the answer for this is it's a fraction. It's a ratio. It's 8 over 17. When do I need that? Well, I need that later when I'm doing some more practical stuff. But for now, that's what I have. Okay? Cosine of alpha. Cosine of alpha is going to be adjacent divided by hypotenuse. And so it's going to be adjacent is 15 divided by the hypotenuse, which is 17. So it's 15 divided by 17. And the tangent is going to be opposite over adjacent, so it's 8 divided by 15. 8 divided by 15. And we have just filled those in. That's all we had to do. That was it. We didn't have to think too hard about it. So now I'm going to switch to theta. When I switch to theta, my perspective on this whole thing changes. So these answers will not be the same as these. Okay, they're going to be different. Let me tell you what doesn't change. The hypotenuse is still the hypotenuse. It is still the longest side because it's the side across from the right angle. So what I'm going to do is erase these two. And if you're thinking ahead, you'll notice that they switch. But I want to explain why. I want to erase opposite and adjacent. Even though you can still read the words on my paper. This is not a very good eraser. From theta, from this angle right here, I want to know what to call this. Well, this 8 is beside it. It is adjacent to it. This side runs right into that angle, so this is adjacent. There it goes. My pencil lead just broke. Barely applied any pressure. And I don't even know where it went. It flew across my desk. Oh well. Maybe this is the pencil. Okay. Well, if this is adjacent, this must be opposite, and here's why. If this is my angle, then the side that is across the triangle from it, opposite. There we go. That's the one I'm dealing with. The side across from it is opposite. So now I'm going to label these, and they're going to be fractions. Sine is opposite divided by hypotenuse. And I'm looking up here when I say that. Cosine of theta is adjacent divided by hypotenuse. And tangent of theta is opposite divided by adjacent. There we go. And now we know the three trigonometric ratios, three trig functions, and we can set things up. That's going to come in handy when we get a little further down. Okay, we are going to solve these for x. Why are we doing that? Well, I'm going to tell you why. Because these are some skills that we're going to need when we get to this, and we're actually doing the practical stuff that people really do in their careers. All right? So we're going to need to do this in order to really gain the skills we need to do this. So let's just hit 1, 2, and 3 really quickly. And as we do that, we need to look at this as what it is. It is a fraction equal to a fraction. When you see that, a lot of times people say cross multiply. And in this case, yes. People often misuse the phrase cross multiply, but in this case, it does work. We will cross multiply, meaning this. 5 times x. Well, that is 5x. And then we will set that equal to whatever we get when we multiply the other way. And that is 4 times 10. There's a reason this works, by the way. And we're going to sort of explore that reason on some of these other two. So 4 times 10 is 40. And at this point, we just say 5 times what gives me 40. And you might could have done this in your head. Let me show you real quick how you would do it. How do you turn a 5 into a 10? You double it. We'll do the same thing here. How do you double the 4? How do you turn this into this? Well, you double it. You do the same thing. If you double the bottom, you double the top. Double the denominator, double the numerator. Which really means, if we do it the way we had started it, x is 8. That's it. Okay, well, number 2, fraction equals a fraction. That ain't a fraction. Oh, yes, it is. Oh, yes, it is. That's 4 over 1, right? There you go. It's 4 over 1. So here goes. We're going to cross multiply. We're going to do 1 times x. Last time I checked, that was x. 1x. Which makes this pretty easy. And then we'll do 4 times 7. And cross multiplication works because if we were going to just solve this anyway, we'd have to multiply by that 7 to get it out of the denominator and have x by itself. That's how cross multiplication even works. So 4 times 7 is going to give me 28. And we're actually done. I know what x is. That's it. This is a way of saying what divided by 7 will give me 4? Well, that'd be 28. 28 divided by 7 gives me 4. Okay, this one is not going to be nearly as obvious. This one's going to have probably a crazy answer. But it is a fraction equal to a fraction. Let's put it over 1. And now let's cross multiply. 1 times 9 is 9. That is equal to whatever we get when we multiply these. This is not one that people can look at and just identify. 3.2 times x. Well, wrong color, not that it matters. But that is 3.2x. All right, how do we solve it? Well, I want to get x by itself, and I have 3.2 times x, and the opposite of multiplication is division, so I'm going to divide by 3.2. There we go. I don't know what it is, so I'll grab a calculator. And I will do 9 divided by 3.2, and I get a decimal. Normally I'm going to round most of these decimals to 2 places, but this one terminates, and so we'll leave it. 2.8125. There we go. We found them. All right. Here goes number 4, number 5, number 6, 7, 8, and 9. We're going to do this whole section at once, but we're going to go through it kind of slowly. All right, let me pull out my pencil that doesn't work. Actually, let me get my other pencil that looks exactly like it. Maybe this one will work, or maybe it's worse. Who knows? Okay, here's what we have. We have a right triangle. No secrets there. Nobody's lost so far. We have a 23-degree angle in a corner. From this angle, we will identify everything else. Here's what I like to do. I'm going to start using H for hypotenuse, O for opposite, and A for adjacent. I might abbreviate and use more than just one letter. I always like to start with a hypotenuse. There it is, hypotenuse. I know that this is the hypotenuse. I have a problem though. I don't know anything about my hypotenuse. I don't know a number. I don't know a letter. I don't know anything. That's okay, I'll deal with it. That's what I just said will come in handy later. What's this one? Is it beside the angle that I have, or is it opposite that angle? Well, it's beside the angle, So I'm going to call it adjacent. I'll call it ADJ. And this one is opposite because this side does not touch that angle. Okay, this is where it gets fun. I have three sides, but I only have two of them labeled. Because I only have two of them labeled, I'm not even going to worry about this hypotenuse. I'm going to erase it, pretend like I don't know a thing about it. Okay? So here's the deal. I have an angle. And along with that angle, I have the opposite side and the adjacent side. What I'm going to do is keep that in mind, opposite and adjacent. Which one of these has opposite and adjacent? It's tangent. This problem, number 4, is going to be a tangent problem because I have the two sides that make up tangent. So let's do it. The tangent of 23 degrees is, okay, tangent is opposite, that's x, divided by adjacent, that's 16. Okay? Here's where it gets really interesting. You have to have a calculator for this. Actually, back in the day, they had tables of these things. They would get, not tables like furniture, but they would have textbooks that would have just page after page after page of all these things listed in there so they could find out what they are. Well, we don't have to do that anymore, and we have tables. Anytime you were doing trigonometry on this level where things are labeled in degrees, then you need to do something that is going to be incredibly important. See the button? It says mode. Press that. And make sure you are in degrees, not radians. There are two ways, well, there's more than that, but two major ways of measuring angles. And one of them is radians. We don't need it for this. One of them is degrees. So change that to degrees. And now we're good to go. And you can tell from looking up here. That should say degree. On most calculators, most more modern calculators, you'll have that. So here's the deal. I don't know what that even is. What does that even mean? Well, this is a number that my calculator will tell me. And that number is the tangent of 23. There you go. I personally am a 2 decimal place kind of guy. That's just my opinion. It depends on the context of the problem. I'm going to round to 2 decimal places, and I'm going to call that 0.42. So tangent of 23 just turned into 0.42. Where does all that come from? Oh, I'd love to explain it, but it's more than we're going to get into in this video. 0.42 is equal to x over 16. Oh, yeah, great. But I'm looking for the length of this side. I'm looking for x. So what do? I multiply by 16. You know what? I cross multiply. You can put that over 1 if you want to. And cross multiply. 1 times x is x. 0.42 times 16. I'm going to just do it. I'm going to do it the easy way. I'm going to press times, and it pulls up the last answer that I typed from what I typed, times 16, and it gives me 6.79. If I do 0.42 times 16, I get 6.72. See, there's going to be a slight difference if you carry the entire answer with you than if you round it off. I'm going to probably write the abbreviated version, but carry the long one with me. So 6.79 is my answer. 6.79 what? Well, it's centimeters. That means this. If I have this triangle, that's a 23-degree angle, this is 16, then that has to be 6.79 centimeters. Okay? Let's do number 5. First place I look is my angle that they gave me. From this angle, I'm going to label everything I can. From 76 degrees, I'm going to label that. Well, I don't even need the angle for this. I know this is the hypotenuse. This one is the opposite or adjacent. Does it touch the 76-degree angle? Does it run into that same corner, or is it across from it? Well, this one is across from it. This one is adjacent to it. Why am I not talking about this one? I mean, you could. You can talk about it and you can say, well, you're opposite. Well, that's fantastic, but it's not labeled. There is no number. There is no letter. There is nothing right here. Absolutely nothing on this side. I don't even need it. It didn't ask for anything, and it's not necessary to solve anything else. Okay? So here goes. I have adjacent and hypotenuse. When I have hypotenuse and adjacent, what do? Well, I slide my paper up. That's what I do. And I look. Adjacent and hypotenuse. Nope, it's not sine. Adjacent and hypotenuse. There you are. It's cosine. So I'm dealing with cosine. Number 5 is a cosine problem. So the cosine of what? Well, don't start mixing up your numbers. Don't get crazy with it. It's the angle measurement. It's the one with the degree symbol. That always comes after sine and cosine and tangent. All right, well, what is cosine? Cosine is adjacent, that's x, over hypotenuse, that's 15. And now I'm ready to solve. I'm ready to solve this thing, and I'm going to solve it right quick like. Here goes. We're in degrees. We're good to go. I want to find out what the cosine of 76 is. Press cosine right there where my finger is. Cosine 76. Close my parentheses. Oops. 0.24. I'm going to write that, but instead I'm actually going to carry that entire decimal with me as I continue. So 0.24 equals x over 15. We are going to cross multiply. Now, if you want to put that over 1, you can. It's not necessary, but I'm going to for the sake of explanation. And we'll do 1 times x. Well, that's x. And then we'll do 0.24 times 15. And I'm not even going to do 0.24 times 15. I'm going to do that whole mess times 15. So I just press times. Pulls up the last answer, times 15. And I have 3.63. 3.63 what? Oh, centimeters. All these are in centimeters. There we go. Okay, I'm going to speed it up a little bit. We go to number 6. Where do we look first? What we look for first is the angle. When we know the angle, we can start labeling sides. I am going to ignore this. Why am I ignoring it? I don't have anything there. I have no numbers. I have no letters. So, don't need it at all. But I do know this and I do know that. From this 73-degree angle, this 20 centimeter side is opposite. From the 73-degree angle, this is adjacent. This is the hypotenuse. You can label it if you want, but I don't need it. So this is adjacent. So then we look at this and we say, well, if I have opposite and adjacent, what do? All right, I have adjacent, I have opposite. I'm looking for adjacent and opposite. Adjacent and opposite. Adjacent and opposite. I found it. It's tangent. Number 6 is a tangent problem. So we're going to write that. Tangent. Of what? Oh, well, don't start mixing up your letters and your numbers and getting all crazy with it. Don't. Okay. Tangent of what? It's always the angle. It's the one with the degree symbol. Sine, cosine, tangent always come in front of a angle measurement. They don't put that 20 there. Don't put the x there. Not yet. That'll come later. But tangent of 73 degrees is equal to opposite over adjacent. I'm going to pause right here and point out something that is in this problem that hasn't happened yet. In the other 2 problems that we did, x was in the numerator and solving it was relatively easy. Now it's going to get a little more complicated, okay? Don't panic. Let's find out what the tangent of 73 is. So we grab our calculator, we'll turn it on, clear that mess out. Tangent of 73 is 3.27. 3.27 equals 20 over x. All right. Notice I left a little space here. I did it on purpose. I'm thinking ahead. I'm going to cross multiply to solve this thing. Let's put it over 1, and we're going to cross multiply. Okay. Just like we did on 1, 2, and 3, We're going to do it right here on number 6. 1 times 20 is 20. 3.27 times x is 3.27x. Okay? We are looking for x. We're going to divide by 3.27. We cross those out. And we have 20 divided by, you know what, this is kind of cool. It's our last answer. Where did I get that from? It's that button right there. See it? If you press second and the negative symbol, pulls up the last answer. And there it is, 611. That way I can write this, but it's actually entering all of it. It's like, you know, 3.27, whatever it was. Oh, something. So 6.11. This makes it a little more accurate. Okay, we're going to do 3 more even faster in this little section. Let's keep moving. Number 7. I'd actually recommend you try these on your own. If you want to mute the video and just sort of work through these and see how far you can get without anybody's help on these videos. And we'll go from there. All right. Number 7. I have a 47-degree angle right there in that corner. Lucky me. You know what else I have? I have a 20-centimeter side and I have an X centimeter side. What I don't have is this. What's that? It's the hypotenuse. You can label it if you want or not if you don't want to. That's up to you, but I don't even need it. What I do need to know is what to call that. What do I call that? Don't say X. Yes, I can call it X, but it is across from this. This never ever will touch that 47-degree angle. Never runs into that corner. This is opposite, and this does run into that corner, therefore it is adjacent. Opposite and adjacent is tangent. Opposite and adjacent is tangent. Tangent of what? It's always the one with the degree symbol. Tangent of 47 degrees equals opposite over adjacent. Let's solve it. I'm going to go fast. You better keep up, boys and girls. Tangent of 47 degrees is 1.07. 1.07. That is equal to x over 20. We will put that over 1 and cross multiply. 1 times x is x. 1.07 times 20, I don't know, whatever 1.0723687 is, times 20. 2145. 2145. There we go. If you were trying this on your own, I hope you got that. Let's keep moving. Pause it if you need to. Let's find the hypotenuse. It's this one. $57 degrees. Let's see, 57 degrees. We need to find that one. Well, this one is the one that's not labeled, so we really don't care what this is. But this 57-degree angle never touches this side right here. That means this is opposite. Okay, opposite and hypotenuse. Which one is that? I have opposite and hypotenuse. Oh my goodness, it's sine. Opposite and hypotenuse. First one I was looking for. Opposite and hypotenuse is sine. Sine of the angle, that's the degree symbol. Sine of 57 is equal to opposite over hypotenuse. Let's find out what that is in the calculator. You can see the reflection of my lamp sitting right there. There's my light bulb. Slide that down. Here's a lamp sitting right over my desk, obviously, as you can tell. See? Oh no, that's my ceiling fan. There's my lamp. Well, you can see all my light sources on this. Anyway, sine, I digress, don't I? Sine 57 is 0.84. So 0.84 equals 20 over x. Put that over 1. I really hope you've got this muted right now and you're trying it on your own. If you're not, please mute it and try it on your own. This gets really boring listening to me talk, saying the same thing over and over. You got this. Do it. 1 times 20 is 20.
0.84 times x. Well, that's 0.84x. 0.84x. I'm looking for my x. I wish I could find her. So we're going to divide. That's a bad joke, wasn't it? 0.84. Divide by 0.84 on both sides. I'm actually not going to divide by 0.84. I'm going to divide by all that. 20 divided by all that last answer right there gives me 23.85. The length of this side is 23.85. There we go. Okay. Number 9. That'll be the last one in this section before we move on. Number 9. The longest side is the hypotenuse. I labeled it, and I don't even care because it doesn't have a variable, it doesn't have a number, it has nothing. There's my angle. This side runs into my angle. It must be adjacent. This side never touches my angle. It must be opposite. Opposite and adjacent are tangent. We've had 4 tangent problems on this. We've only had one sine and one cosine. Isn't that sad? Sine and cosine feel left out. This is tangent of your angle equals opposite. 15 divided by adjacent is x. Find out what that is. Tangent 39. I got 81 cents. 15 over x. Notice the x is in the bottom like it was over here. Put it over 1. Cross multiply. 1 times 15 is 15. 0.81x. We're going to divide by 0.81. And x equals whatever 15 divided by that last answer was 1852. There we go. Number 10. Number 10. Here we go. These are different. Well, first of all, they're hand-drawn as opposed to typed, as you can tell. But in addition to that, let's notice the difference. There's that Greek letter theta crammed up in the corner on each one of them. And that, what does that mean? That means I don't know the measure of the angle. Oh, see, all right, let's back up for a second. I did know the measure of the angle here and here and here. I don't know it here. I don't know it. That's okay. From this angle, from theta, what would I call this? Using this as a reference, what would I call this? Would I call it opposite, adjacent, or hypotenuse? Well, it's not hypotenuse. Hypotenuse is the longest side. That must be this one. It's not adjacent. This is adjacent. Since that's adjacent because it runs into that corner that holds that theta, then this one must be opposite because this doesn't run into that corner that holds that theta. So this one's opposite. I have opposite and hypotenuse. Well, what's that? Opposite and hypotenuse is sine. Okay? So here goes. Sine of what? Well, notice what I told you here. Sine of what? Well, sine of your angle. What is my angle? I don't know. It's theta. Sine of theta. It's that Greek letter theta. Is equal to opposite divided by hypotenuse. Well, how in the world do you solve that? What in the world do you do? You don't divide by sine. Let's see, sine, cosine, and tangent, those are operations that you do on numbers. It looks like you'd be multiplying or something, but you're not. You're not. It's the sine of a number. Sine of some angle gives me this. Well, how do I figure it out? Here's how. Okay, again, let's make sure we're in degrees, and we're not. I mean, we are. If we're not, you'd press mode, and you'd make sure you're in degrees and not radians, because we're dealing with degrees here. So what we're going to do is find that by doing the opposite of sine, what we call the inverse of sine. Some people call it arc sine. It's often called that, but I'm going to call it inverse. It's the same idea. And it's this. It's the sine button, but see that little sine to the -1 power? You hit second and sine, and it pulls up that. And what this does is it tells me the measure of the angle, 4/13. And I just type 4 divided by 13, and there we go. Now, I'm normally a 2 decimal place kind of guy, but when it comes to angles, I normally don't. I don't know why. I'm just going to round to the nearest whole number. So I'm going to say that theta is 18 degrees. This is roughly an 18-degree angle. And I found it. Now, if you wanted to get technical, and I want to prove something to you here. If I find the sine of 18, since theta is 18, I would get that. If I type 4 divided by 13, I should get that. Now, it's not going to be exactly that because I've rounded, but it's going to be close to that. See? About the same thing. Isn't that neat? Okay, let's do the next one. This is my angle of reference. This is where I'm going from. From this theta, what will I call this? Is it adjacent, opposite, hypotenuse? What is it? Well, this one's the hypotenuse. I don't need it, but it's the hypotenuse. Since I don't need it, I'm going to erase it. This one is adjacent. It's beside it, so adjacent. And this one is opposite because it doesn't touch it. Adjacent and opposite are tangent. So, the tangent of my angle is opposite, that's 8, over adjacent is 4. Now, if you want to go ahead and make your life easier, 8 divided by 4 is 2. You're right, I'm right, we're right, we got this. But I'm not going to go there. Instead, I'm just going to go ahead and do what I did on the last one. I don't know the measure of my angle, so I'm just going to press inverse tangent of 8 divided by 4. You could put a 2 there instead. And I'm going to round to the nearest whole number because I'm dealing with the angle measurement. Personal preference. That's just my personal convention on that. 63 degrees. You don't have to do what I'm about to do right now, but I just want to prove it to you. The tangent of 63 degrees. When I press enter, I should get something that's awfully close to 2. Pretty much. $1.96. That's pretty close to 2. Because we rounded, it's not exact. But there we go. All right, let's do one more in this section. Try it on your own, please. Mute me if you feel like it. There's my angle. This is my hypotenuse. That rules out tangent. I'll tell you that right now. This is adjacent. Adjacent and hypotenuse are cosine. So the cosine of my angle is adjacent over hypotenuse. All right, looking for the measure of an angle. There's my ceiling fan. You see it? There's my lamp. Let's do it. Looking for the measure of an angle. I can't press cosine. I have to press inverse cosine. Second and cosine, and then 4 over 13. And I end up with a 72-degree angle. 72 degrees. There we go. Found it. If you're looking for the measure of an angle, you will not press sine, cosine, or tangent. You will go inverse sine, inverse cosine, or inverse tangent. It's second sine, second cosine, second tangent. It's one of those. Word problems. These scare people. I don't know why. Draw a picture. Really, it actually gets kind of fun when you start drawing the pictures. You're lying on the ground. Well, draw it. There's the ground. There's you. You're laying on the ground. There you go. Man, isn't that fun? You're 45 feet from a tree. Well, draw a tree. Don't draw the tree right beside you. That ain't 45 feet. There's your tree. I can't draw. Let's make the top of the tree green. There's some foliage on that thing. There we go. I'm 45 feet from a tree. The angle of elevation. Elevation? What's that mean? Elevators do what? Go up. Well, and down too. And escalators go, well, that's a terrible example. But elevation is up. So what we're doing is we're looking up. You're laying on the ground. Why are you laying? Because I don't want us to take your height into consideration. That slightly complicates the problem. So you're looking up at the top of the tree. I don't know if you noticed this, but we just drew a triangle. And if I'd have drawn it right and had level ground, that'd have been a right triangle. See? See it? Okay, let's start labeling some stuff. Don't make word problems harder than they are. Draw a picture. You're lying on the ground 45 feet from the tree. There's you, there's the tree. That's 45. The angle of elevation as you view the top of the tree is 69 degrees. 69 degrees. How tall is the tree? Well, let's talk about the tree. That ain't the tree. That's the tree. And it asked for the height of the tree, so that's your x. If the person and the tree and all this is complicating your life, don't worry about it. Here it is. Here's your picture. 69-degree angle, 45, and x. That's really what I have. And now it's exactly like the problems that you've been doing. Okay, grabbing a pencil. From 69 degrees, this is opposite. This is adjacent. At this point, it's a problem that you've dealt with. You know what you're doing. Opposite and adjacent is tangent. The tangent of 69 degrees is opposite over adjacent. There we go. I do know the angle measure, so I'm not going to put theta in there. I'm just going to put 69 in there. So, tangent of 69, I grab my calculator. I find out what the tangent of 69 is, and I get it. Please mute this right now and do this without listening, and then look up to check your answer. Please. 2.61 equals x over 45. Cross multiply. Because it should be muted, I'm going to quit talking. There we go. I'll start talking again. 117.23 what? I'll just say a number. What does it mean in the context of a problem? Well, I'm lying on the ground looking at a tree. I'm 45 feet from the tree. We're dealing with feet here. This is how tall that tree is. It's a pretty tall tree. Okay? Number 14. Draw it. 25-foot ladder is leaning against the side of a building. Well, let's draw a picture. Here's a building. There's a ladder leaning against the side of it. It better be sitting on the ground, though. We're going to assume that. Here's your ladder. There you go. See it? Look real close, you'll see a triangle down in there. Isn't that cute? The ladder makes a 74-degree angle with the ground, okay? Well, we're assuming the building's not leaning, so it's a right angle. And it makes a 74-degree angle with the ground. That ain't up here. That's the building. Here it is, 74 degrees. How tall up the building does the ladder go? So it's asking how high up the building the ladder goes. That's what it's asking. Well, I know one more thing that I haven't labeled yet, and it's this. I know the length of the ladder. I know it's 25. Okay, my picture is very cluttered, so I'm going to redraw it in simplest form right over here. I'm looking for that. I know that. I know that's a right angle. And I know that's 74. Please, please, please mute this right now. Try it on your own. All right, that was it. Number 15. 70-foot tall telephone pole has a guy wire. Those are the wires that come down from the side of a telephone pole to keep it from leaning, kind of support it. 107 feet long. It's attached to the top of the pole. What angle does the guy wire make with the ground? What in the world? Don't panic. Draw it. Telephone pole. Sitting in the ground. There's a wire attached to the top of it that runs to the ground. you have a right triangle. There you go. Telephone pole 70 feet tall. The wire is 107 feet long. And it's attached to the top of the pole. What angle? Oh, it's asking for the angle. It's asking for an angle. It's going to look like one of these. And I'm going to use the letter theta, so I'll kind of know that it's dealing with an angle. What angle does the guy wire, make with the ground? That's this one. That's this angle right here. The wire and the ground meet right here. Okay, I have a theta. I know the hypotenuse. I know the opposite side. And it's time for me to get to work. Opposite and hypotenuse is sine. Sine of what? I don't know. I'll call it theta. Is equal to opposite over hypotenuse. And I'm going to find that right now. Inverse. Sine of opposite over hypotenuse. I'm going to round to the nearest degree because that's what I do with these. You don't have to, but I'm going to. 41 degrees. There we go.